Welcome back everyone to Learning by Teaching. Today we're in dynamics and we're going to solve problem 12.212. The girl at sea stands near the edge of the pier and pulls in the rope horizontally at a constant speed of 6 feet per second. Determine how fast the boat approaches the pier at the instant the rope length AV is equal to 50 feet. Alright, so what we're given in here is that this girl is pulling our boat with this rope, right? And the question is asking us to find basically the velocity at what this boat is approaching our pier. And for that, we need to find the velocity of this segment that they call XB. Okay, so we need to find the velocity of XB. So in order to start this problem, what I'd like to do first, so let's write our givens. We're given that the speed at which she's pulling this rope is 6 feet per second, meaning that the speed of my point Z is that one, is 6 feet per second. So speed of my point C is equal to 6 feet per second. And they're also giving us that the length of the rope AB from A to B is equal to 50 feet. Okay, and AB is from A and B. Okay, so now after having our givens, let's write what is an equation for the total length of this rope. So we're gonna have L for our length has to be equal to what? Well, we have the length from point C to my point A, so XC that the problem is given, and we also have the length from A to B. Okay, so we have plus AB. Now, if we take the time derivative of this, we don't want to plug in the numbers. So what we're going to do, and if we want to find the velocity of B, we're going to replace this length AB in terms of my point B. And how can we do that? Well, we can relate my length AB with my length XB by this triangular shape, okay? So what we can say is that AB is the hypotenuse and is going to be equal to the square root of the adjacent, which is XB squared, plus my opposite square, which is A squared. And as we can see here, this will be the height of my opposite. So let's replace that into our equation. So we have L is equal to XC plus the square root of XB squared plus 8 squared. Okay, so now we can take the time derivative. So let's take the time derivative, and if we take the time derivative of this equation, well, the length of the rope is going to be the same with respect to time, so therefore it's going to be 0 because the derivative of a constant is 0. Then we have the derivative of my point C is going to be my velocity at Z plus the derivative of this root. Okay, so first we need to take the derivative of the root, which is going to be 1/2 times, we keep everything inside the parentheses the same, however we subtract 1 from the power. Then we multiply by the derivative of the inside, which is going to be 2xb, and we multiply by the derivative of xb. So all of this is just us doing chain rule. Now, as we can see, we can cancel this 2 with that 2. So let's take it away. And we can say that 0 is equal to my velocity at C plus, I'm going to bring this root to the bottom because the power is negative. So we're going to have the square root at the bottom of xb squared plus 8 squared. And on top, we're going to have xb times the derivative of xb, or velocity of xb. Okay, so our main goal is to solve for this velocity. So let's solve for that velocity. Let's see what we have. Well, if we solve for that velocity, we're going to have that the velocity is going to be equal to what? Well, we have negative the velocity of c, then we multiply it by the square root. The square root that is at the bottom passes to be a multiplication on the other side, and then we divide it by the length xb. So we have xb, and this is our equation for our velocity. So let's check this out. So which numbers do we have? We have the velocity at c. We know that this is just 8 squared, but we're missing the length of xb at this instant that we want to evaluate this equation. The good thing is that we have an equation in here where we can solve for xb. So if we solve for xb in this equation, what do we have? Well, xb will be equal to the the square root of ab squared minus my opposite square. And if we plug in the numbers for AB, we're going to have 50 squared minus 8 squared. And this will give me a total of 49.3 feet when we plug this into our calculator, okay? So now that we know our XB, we can check mark it. So we know this one and we know this one. We can plug in the numbers. So if we plug that in, we got negative 6 feet per second multiplied by this square root, which is our 49.3 square plus 8 square. And this is a square root, all divided by xb, which is 49.3. Okay? And if we plug this into our calculator, let's see how much do we get. We get a total of negative 6.08 if we round out to 2 decimal places, feet per second. Okay? Now, as you guys can see, we have a negative in front of our answer, meaning that our velocity is negative. So let's go and check out what that means. And as we can see, our length b is supposedly going to the right. However, our answer was negative. Therefore, we're going to the left, which makes sense with respect to the velocity that the girl is pulling our rope. Okay, so that means that our boat is approaching by a total of 6.08 feet per second to the left. So we can write it also as 6.08 feet per second going to my left. Okay, and this should be our answer for this problem. So if you guys like the video, please push the like button, subscribe, and I'll see you guys in the next one.